So welcome to lesson 1. Hopefully there won't be too many of these and we'll be back at school soon. But if not, we'll make do with some of these. Lesson objective for today. You'll be defining the mole. We'll be looking at molar mass and Avogadro's constant. And then you will be applying all three of these concepts to some mathematical problems. Avogadro's constant is just that. It's a number. And what does it mean? It's the total number of atoms or particles that you'll find in a mole. So if you come across a mole of a substance, say a mole of oxygen or a mole of carbon, then the specific amount of particles, atoms, that are in that mole of the substance is equal to 6.02 times 10 to the 23. In physics, we use it to 3 significant figures. So this last 2 you can disregard, and we will always be using it in the form 6.02 times 10 to the 23. That's how many particles in a mole. And here we have the IB definition. 1 mole of a substance is the amount of the substance that contains as many particles as there are exactly in 12 grams of carbon-12. And how many atoms are there in 12 grams of carbon-12? The magic number. The next concept is the molar mass of a substance. This is defined as the mass that contains 1 mole of its defining particles. So, molar mass, capital M, important that you remember this notation, capital M, is the mass of 1 mole of a substance. So, a few simple ideas there, but suddenly going to get a little bit more complicated. Let's review the ideas we already have. We have molar mass, capital M, and we have number of moles, which is little n. Now, let's bring in this idea of mass m. Let's say we bring any mass m, a given sample of mass m of a substance. This is always represented by a small m. Now, we can find the number of moles from the molar mass and the mass or the given sample of a substance. So how do we do that? We find the number of moles is equal to the given mass divided by the molar mass. So this is relationship 1. Now, say we wanted to find not the number of moles, which is little n, but we actually want to know how many particles are in the sample. Now, particles could be atoms, or it could be molecules. It doesn't really matter. How do we find that number, capital N? Well, if we know Avogadro's constant, which we do, it's a constant, it's on the data booklet, and we know the number of moles, then we can actually find the total number of particles by multiplying the number of moles and Avogadro's constant. The equation is actually in the data booklet, but it looks like this. So let's try a quick example. We have a molar mass of water, which is 18 grams per mole. How many molecules are there in 1 kilogram of water? Well, we've got a value for capital M, and we have a value for small m. We have a molar mass of 18 and a given mass of 1,000. So if we divide the mass that we're given by the molar mass, we should be able to get the number of moles. Now, as you can see in this question, I've decided to change the 1,000 into grams, right? This was actually 1 kilogram, but I've changed it into grams. I could have done it the other way around. It would have been more, well, not more correct. It's probably more standard to change everything into kilograms, but it doesn't really matter in this case, as long as both sides, or both sides of this fraction, are in the same units. So did you get the right answer? You should have got a number of mole equal to 55.6. You can then work out the number of molecules by using Avogadro's constant. The Avogadro's constant, Na, multiplied by the number of moles. And that gives you the total number of molecules. Before you start doing the numerical questions, you might want to watch this video, which I've attached in Classroom, just to reinforce some of the ideas. Complete as many questions as you feel that you need to do in order to get the ideas fully cemented in your brain. The answers will also be posted on Classroom as well as on the presentation. Take care and see you soon.